Good morning, everybody. Welcome to series Kuliah dalam Talian or KUAT. Okay, for those who didn't know what KUAT is actually an activity set up by the Muzium dan Galeri Tuanku Fauziah as a platform, as a platform to discuss, to have a lecture, something to do with the integration of arts and science. Okay, so since our museum aims to to promote more balance in art and science. Just like Prof. Madia Hasnul Jamal just said, we have to balance both of our brain, right brain and left brain. So this platform is actually well, we're not hoping for a very formal platform. We just having a discussion, we're just having a talk with our friends. Okay, so we just want to get involved in what we understand about the arts and science. Okay, so today we have Dr. Mariko here. Dr. Mariko is from the University of Philippines. Okay, good morning, Dr. Mariko. How are you?
Very fine, thank you.
All right. So today, the title of the talk for today is Science in the Service of Arts, Tales of Cultural Heritage Conservation on the Budget. Okay, so I'm going to do some introduction first. Okay, first of all, I'm going to introduce Dr. Mariko. Okay, Dr. Mariko Sariano is a professor of physics at the University of the Philippines, who specialize in developing hardware and software tools for video and image processing. Her work spans multidisciplinary, such as coral reef imaging, and she won a prize in 2018. Okay, and she also done some work in cultural heritage conservation, video analysis of sports, and medical imaging. And for her innovation and inclusive research, she was awarded a Leaders of Innovation Fellowship by the UK Newton Fund in 2015. And she also received the award of the Outstanding Woman in the National Service in Applied Physics in 2013, and the Outstanding Young Scientist Award by the National Research Council of the Philippines in 2006. Okay, so that's a little bit about about Dr. Mariko, and now I'm going to read some of the abstract of the talk today. Okay, so the title of the talk today again: the Science in the Service of Arts, Tales of Cultural Heritage Conservation on a Budget. Okay, basically in this talk today, Dr. Mariko will report the various activities of her group, the Video and Image Processing Group in Cultural Heritage Conservation. Okay, the team used physics and easily accessible equipment and resources to conduct research on arts analysis, archiving, digital training, and change detection. Okay, the team's goal is to demonstrate to museum and art researchers that scientific analysis and some conservation works can be done even under a low budget. Okay, so the work presented here are the thesis and project of Dr. Mariko's student, collaborators, and Dr. Mariko herself, who embarked on from 2006 to the present. Okay, so I don't want to take a lot of time here. So I think I'm gonna let Dr. Mariko to start her talk today. So please, Dr. Mariko.
Thank you. Good morning, everybody. Do please tell me if I'm speaking too fast. Don't hesitate to interrupt me if I'm speaking too fast. May I share my slides? Can you confirm? I think you're seeing my slides now. Okay. So once again, thank you to the organizers for having me. So this is the title of my talk, Science in the Service of Art, Tales of Cultural Heritage Conservation on a Budget. Let me tell you a bit of something about myself and my group first. So relative to USM, this is where we are here in the Philippines, here in Quezon City. And I'm from the University of the Philippines, College of Science. And this is how our National Science Complex looks like. Welcome to visit us here after the pandemic. So these are buildings of the College of Science. This is our institute, the National Institute of Physics. So you might think, what is a physicist doing in art? In this building, our laboratory is in this corner here. Okay, so we call ourselves the VIP because the name of our group is Video and Image Processing. So here's our logo, and it looks like a fish or a person running or an eye, and it has many connotations actually because we have done a lot of multidisciplinary work. So our group or the laboratory, the aim of the laboratory is actually to train students. These are physics students, bachelor's, master's, and PhD students in physics. And I give them projects. I give them the problems usually coming from these projects, or sometimes their thesis problem is something of their interest. So the culmination of our training of these students, so they do research in the lab, is of course their thesis defense. So it's a celebration when they finally defend their thesis. But it's not all hard work. We also know how to have fun. We excel also in cosplaying. So before the pandemic, it's always if there is a party and there is cosplay, we go all out. And as you can see here, we like creating artistic renditions of either characters or themes. Like here in this Christmas party, we were told to wear something green. So anything green. And here we were asked to wear something Disney characters. We know how to have fun. Now, coming back to the work that we do. So we are a very multidisciplinary group. We try to help any agency that has a problem involving image or video, which is why our research interests are quite all over the place, as you may see. We do heritage conservation, coral reef imaging, video biomechanics, forensics, and there are many others. Doesn't fit here, so I don't write it anymore. But I'll focus today on heritage conservation. By the way, as Professor Hasnul Saidon said earlier, we've met before. They actually came to the Philippines, and our meeting there, my team and I got invited to Penang. So I was here back in December 2010. In fact, this is our picture together. So Professor Hasnul still has the mustache and goatee and looking like a rock star. And here's a group picture of us because I enjoyed really Penang. I really enjoyed. So thank you very much for having us. It was really a feast, not only for the stomach, but also in art. Very nice place. So I have very fond memories of our time in Penang. So you can see here one of my students. She had. I will discuss a bit of her work in this research, in this talk rather. Okay, so now let's go to what we do. So essentially, heritage conservation, and what we do is we try to use tools that are easily accessible so that museums with low income can see that they can also do this on their own. Our My work on art started back in 2006 when a curator of the University Museum, the Jorge Vargas Museum, invited me to craft a project on museum. So we had this Art Beyond Appearance project. It went from 2007 to 2010. And in this work, we tried to study the works of our first national artist. His name is Fernando Cueto Amorsolo. He is an oil painter, and he is well known for his portraits and for painting rural scenes of the Philippines, just like what you see here. However, he is one of the most forged artists in the Philippines because back then, when some people like one of his paintings, however, it's already sold to a client, he will make another copy and sell it to another customer. So he was known to make copies of his paintings. And therefore, there was a time that there were many fake copies of Amorsolo's painting, which were being sold as his. So there was a forgery going on. And it was difficult to authenticate because Amorsolo was known to copy himself. Okay, so uh, the curator asked me, is there a scientific way of determining if a painting is really made by an artist or not? Which was why we decided that what if we look at the statistics of the painting? Perhaps the statistics will not lie. So, what happened was our turn towards looking at the color choices of Amorsolo went towards digital restoration. How many of you follow Julian Baumgartner in YouTube? So he's a restorer. He has a YouTube channel called Baumgartner Restoration, and he shows how paintings are conserved or restored. And usually, perhaps you know that it's usually like this. There is a cotton swab dipped in some solvent, which removes, and you rub the cotton swab with a solution on the painting to remove grime, dirt, and even old varnish. Okay? Now, actually, there had been research on doing this digitally. And the trick is from a clean part of the painting, determine a mathematical transformation such that you can convert pixels, dirty pixels. For example, you take a digital image of the painting, including a part which you partially cleaned, so you know what the color should look like if it is cleaned. And you determine a mathematical transformation from dirty pixel to clean pixel. And in fact, many people, many researchers have been trying to do this, and there have been many mathematical transformations that have been proposed. So you see here some of the papers that have tried this techniques and introduced different mathematical transformations. All right, so we went towards restoration because of this painting. Okay, originally what we wanted was to study the color choices of Amorsolo. So we wanted to sample the colors using a spectrometer of this particular painting. This is Malacanang by the river. This is the office of the President of the Philippines. It is still being used today, but in the past, this used to be the official residence of the Spanish Governor General of the Philippines, and it is beside our river, Pasig River. And this is a colorful painting, except that it looks dirty. You can see there is red, green, white, brown, blue skies, white clouds, etc. Now, we were about to measure the colors all around this painting. And so the museum researchers removed the frame that was holding the painting. When the frame was removed, we noticed something. At the corners where the painting was covered by the frame, partially covered by the frame, we noticed that there was a very clear, a very distinct difference between the dirty part. This was most likely exposed, and this was most likely hidden by the wooden part of the frame. And so we see a very distinct difference between the two. Now we look at another corner, at the lower right corner, we look at it in close-up, we again see the distinction between the dirty exposed part and the clean hidden part. And we said, don't the digital restoration techniques need this information, this kind of information, if you already have examples of how the paint will look if clean, and you also have, of course, the dirty appearance of the paint, perhaps we can create a mathematical transformation given these examples of colors. Fortunately, the painting, all around the painting at the corners, which were hidden by the frame, fortunately had samples of the colors that we need. For example, there is red up at around this corner. This is the flowers from a fire tree, which are very bright red, and the green foliage from the trees, and the river, of course, and the blue sky and the white clouds. Fortunately, there were samples of this color all around the edges. And so what we did was, instead of finding a mathematical transformation, we let the mathematical model of how the brain learns, it's called the neural network, learn from these examples of clean and dirty pixels. And so that's what we did. We trained a neural network to map a dirty pixel to its equivalent clean pixel. And so this is the result. Okay, and we call this, of course, digital cleaning. After what is digital restoration? What is being done in digital restoration? Digital cleaning. Now, here's a close-up view of the original painting. So how do we know if it's digitally cleaned? We say, so this is the clean version. We say that it is somewhat cleaned if the transition from the hidden clean part and the dirty part is more or less smooth now. As you can see, it's rather looking similar, right? So once again, let's go back to the dirty, grimy painting and then go forward to the digitally clean painting. One might argue, but again, this is not physical cleaning. This is done on the image or the digital image of the painting, a picture of the painting. One might argue, hey, but I can do that using Photoshop. Oh, actually, we tried. We tried doing that using Photoshop. But what happens was the Photoshop would look for the same set of RGB colors and transfer those colors to all similar RGBs. So it failed using just Photoshop. Okay, so this is more intelligent because you give it a sample of what the color should look like, and it transforms it to the color that it's expected. It's not perfect, as you can see. There still seems to be some grime on the clouds, but at the very least, the dirt has been reduced. We went a little further. Originally, this was what we were going to do. These are museum researchers on one of Ras Amersolo's painting. They're using a spectrometer and they're pointing it at points on the painting to see the reflectance spectrum of the painting, okay, at different parts. And we wanted to measure those. A spectrometer typically looks like this, and that's the cost. But we found that we can make a spectrometer just by using a digital camera. You can convert a digital camera into a spectrometer. A spectrum, just like this, is essentially how much of each color of the rainbow a surface reflects. Okay? So a spectrometer measures that kind of reflectance. And using a database of all the possible reflectance of pigments, we were able to do that. And so the idea is you take a digital image of the painting, of course, in the database of Munsell color chips. Perhaps you've heard about Munsell color chips. These are reference colors in a book form. There are reflectance measurements of these Munsell color chips. And we wrote the software to recreate the reflectance from RGB or red, green, blue digital color to reflectance. And as you can see here, these red lines here are the reflectance, and the black lines are the recovered reflectance from digital camera. So more or less, it approaches the reflectance. And what we did, because anyway, we already have a digital image of the painting before it was cleaned, and we now have a digitally cleaned painting. What if per pixel, we convert each of the pixels into reflectance? Essentially, for example, let's take a pixel in the dirty painting, a point in the painting, and at the same location in the cleaned painting, let's also take the reflectance. So here's a pixel. It looks like this before cleaning. We convert the color into a spectrum. And then after digital cleaning, we got also the spectrum, and it looks like this. We say, wait a minute, isn't a dirty layer similar to something like a multiplication? Because it's like you're looking at it through a filter, a dirty filter. So what we did is we just simply element per element divided this graph by this graph, and we got this graph. And then rendered it, and we found this color. And we were going bananas when we saw this color because, hey, this looks brownish. And isn't old dirty varnish brownish like this? Perhaps it could be grime or dirt, but this looks like, it looks like something that you would expect from a painting that has varnish that has already decayed. And so we did that for the whole painting. And so we were able to visualize how we call it the dirt layer, how each painting or what was removed from the dirty painting, an image of the discoloration, as you may, from the dirty painting. This already includes everything. It can be dirt, grime, uh, color fastness, decayed varnish, which is why you have some strange colors there. Okay, and this is the first time that because we have seen that many people try to do digital restoration, but we haven't seen anybody who has done a visualization of what was removed from the painting after digital cleaning. And so we published this result, and this is open. You can get a copy of this paper, and this is downloadable freely at Optics Express. Okay? So you can have a copy of this paper to study what we did. Okay? And this was the thesis, master's thesis of my student. She was with me when we were here in Penang back in 2010. Okay? Cherry May Palomero. Okay. Next is what we next did was on 3D imaging. Oh, okay. Now, I think some of you already have some apps on your phones that allow you to take pictures of an object in different positions. No, you take your camera and here's your object, and you take a photo of that at different camera positions, and there's an app that converts the object into a 3D image. And with the rise of 3D printing, this kind of 3D imaging is becoming more popular and more accessible. The only problem with that kind of imaging is it's not as accurate as pixel accurate, meaning there are some points in the depth map or the 3D image that are interpolated, meaning it is assumed to have that value. Okay? Imagine if you have a 3D imaging technique that is very accurate, pixel accurate, meaning per pixel, you have information about the depth of the image. There are many 3D imaging techniques, and this is what we call a pixel-rich 3D representation because each pixel can have a height information or a depth information. The common stereometry techniques that are used in smartphones, for example, their photogrammetry, their stereometry, they are structure from motion. These are usually interpolated 3D shapes, okay? This will matter because what if you're looking at brush strokes? These are very fine details, so you would like to have as much detail as possible. Now, we saw a technique that allows you to take 3D images of heritage objects just by using a projector, projector, office projector or class projector, and of course a digital camera. And the nice thing about this is you can bring it in the field. For example, the previous picture is a picture of the Angono petroglyphs. These are rock art carved on a rock shelter. Okay, it's around 40 kilometers from our university, so it's easy to access. We just have to travel 1 hour to 1 hour and a half to get there. And so once again, thesis of my students, we can bring the projector and the camera on the site and try and take 3D images of this rock art. Okay? Now, how does it work? Think about this. If you project a straight line, you can create a pattern on Microsoft PowerPoint, yes? Like for example, straight lines. What happens if you project it on a white screen? No? What happens when you stand in front of the white screen and the lines are projected on your face? Notice that the straight lines will now look curved because it follows the contours of your face. The change in the straightness of the lines tell about the depth or the height of the object, and that gives us a tip about what is the shape of the object or the surface of the object based on this distorted line patterns. And essentially, that is what is being done in this technique, right? And because of that, we are able to have a look here. This is very pixel rich, meaning per pixel. This is one of the rock art because there are 127 figures of either animals or people in that rock shelter. They counted 127. We tried to take a 3D image of each of these, no? And a pixel rich or a very accurate a representation. So here is how it looks in close up. So as you can see, pixel per pixel, there is a height map. You can take a line here and take a look at the profile, right? So you can see this part is where this graving mark, this deep part here, and the other there's an indentation of the rock here, and then another grooving mark here as well, right? Now, this is what we wanted to do here. The question that was being asked here is, how old are these carvings? Because all the anthropologists guessed that it was probably 3000 BC. But there is actually no test. This was just an estimate, but there had been no test to measure the age. And we tried to research on that. What we can only do perhaps is what is called relative aging. Relative aging, not absolute aging. Perhaps you've heard about carbon dating. Yeah, you measure how many carbon atoms are still there in active carbon. But if you do that on this rock, you measure the age of the rock, not the age of, or rather the date when the rock was chiseled. So you cannot do carbon dating on this. So what we wanted to see is perhaps let us take a look at the carvings and perhaps try and measure erosion rates. Perhaps the erosion rates can give us a clue. So that was what we were trying to do. And the first step was to create a 3D image. Unfortunately, somebody did some vandalism near where the rock art was. This is a site which was protected by our National Museum. However, unfortunately, some people have been vandalizing or carving their names. And so we took a 3D of that as well. So the name here was, it was very long, Nilo Villamer. No? The name was long. But we took a sample because, okay, at the very least, we have a sample of a freshly carved grooving mark. And we can compare that with the ancient carvings. As you can see, they are deep, sharp, okay? And this is how it looks like in 3D. As you can see again, it is pixel rich. You can even see the granularity of the rock. That's how accurate it can be for a pixel rich technique like this. So here we've converted the edge now into millimeters so that we can study how deep the grooving marks are. They're actually fairly deep. Some are fairly deep. Yeah. Okay, because of our work on this rock art and doing 3D, we were invited in 2011 to 2012 to investigate a stone which was found in an island in the Philippines, which had writings. Okay? And this is now called the Tikau stone, and they are now in the National Museum. Back in 2010, anthropologist Dr. Francisco Datar reported the discovery of two limestones which had writings. This is our ancient script. It is called Baybayin. Okay? And there were two stones, one small one and our larger one. Both sides had carvings of these figures. No? We were asked because one of his assistants used to be my assistant. When we had that project in Vargas Museum, my former museum researcher assistant became his assistant. And when he was talking about the rock art, that assistant said, you know, Dr. Maricor Sariano can do 3D of that stone. Oh, can we invite her over to investigate? And so we had the phone call and he explained what was going on. And he said, would you like us to visit so that you can take a 3D of the stone? And I said, yes, we can do that. We can simply carry our projector and our camera and our laptop, and yes, we can do that. And so on July of that year, that was, I think, 2011, we traveled from UP Diliman by bus to that part of the country near the east, and we traveled and we traveled and we crossed the sea. It took us around 10 to 12 hours by land. There were storms, and so there was a risk. We could have flown using an airplane, but there was a storm brewing, and we were afraid that once the storm hits this place, the airplane might be asked to just go back to Manila. So we decided to lessen the risk by doing land travel, and then we crossed the sea and reached this island where the stones were found. So this is Tikau Island, and this was me when the first time I saw the stone. So that's how it looks like. It's a limestone, a yellow brown. It has both sides covered in writings, Baybayin writings. And Dr. Datar was the one holding the stone. Huh? We are in the house of school principal, Virginia Almodal. Let me tell you the story. So here's a close-up of the stone. Okay. This is just one side of the stone. And this is the little stone. Huh? Now, the story goes is that back in 2000, this was actually found in an elementary school. There was an elementary school in Tikau, which has, of course, the school grounds was very large, but it was muddy during rainy season. The principal back then told the students, go around school grounds and look for a flat stone, which we can use to rub your sandals of mud, because when it is rainy season, the soil becomes muddy. The children come in the classroom, their slippers are full of mud. So the classroom becomes very muddy. And so the principal said, look for a flat stone, which we can use as a mat, footpath, so that you can rub the mud from your slippers. So the children went around the campus, the school grounds, and found this large stone. It was nice and flat. So they said, this looks like a good mat. They right away noticed that there were carvings on the stone. And beside it, there was this small stone with the carvings as well. It was kind of heavy. I think it was 20 plus kilos. So several students carried it uh, and put it in front of a classroom. The small stone, the teachers kept in a cabinet, but the large stone was placed in front of a grade 4 classroom. And for 10 years, students would come in and rub their slippers on that stone for 10 years. After 10 years, a new principal was assigned to the classroom, to the school. Her name is Virginia Almodal. Now, principals in the Philippines are required to have some advanced studies to enrich themselves, no, and enrich their knowledge. Fortunately, Ma'am Virginia Almodal studied uh, some bit of ancient history and is aware of the baybayin, or the Philippines uh, ancient writing system before the Spaniards came. And so she was told, ma'am, do you know that that stone in front of the grade 4 classroom has baybayin carvings on it? She said, huh. So she immediately ordered the stone to be removed from the floor, and she cleaned it. She cleaned it herself, and she was crying while she was cleaning the stone because she understood this must have been an important artifact. For 10 years, it was being used as a footmat. So she was crying while she was cleaning the stone. Now, as you can see, the stone has carvings, and so the mud and some soil uh, got collected on those grooving marks. So she asked some of the elementary school children to help her clean by picking out the mud or the soil from the writings. The students looked for something sharp and they found nails. And so they used nails to pick out the mud from the carvings. And of course, since these are students, young students, one of their lessons is how to write. They're copying what they see, right? And so, as you can see here, perhaps one of the kids tried copying this symbol here and using the nails carve the same symbol here. So a bit of artifact got included. We can call it vandalism because they don't know any better, these poor kids. So the kids, they're used to these lessons, no, copying. So maybe one of those times that they were, okay, I'll copy this symbol, ching, like that. Okay. So when we got to the stone, we saw this and we were told about what happened there. So my task was to take 3D images of each of these symbols, okay? Because there were a few experts back in the University of the Philippines who cannot travel to this place. It was very difficult to reach. And they would like to study the carvings even while they're there. So when I came back, I had 3D images of these letters. Okay. This is called the baybayin. This is a syllabary. It's not an alphabet. It is a syllabary. The way we had writings before was a syllabary, meaning each symbol is a syllable. Like, for example, I don't know if it's similar to yours, but for example, this thing that looks like an inverted heart is ba and ka, da or ra, ga, ha. And we used a symbol called kudlit. It's a dot. If we put it on top, the ba becomes a be or a b. If we put the dot at the bottom, then it becomes a bo or bu. So that's how we change the syllables. And this is very rare because in the Philippines, there are many baybayin writings on paper, but this is just the sixth artifact that has baybayin writings on a solid object, on clay, or rather on limestone, because this is ivory, silver, clay. This is copper. This is copper. Okay. So the big questions that that the scientists were asking was, when was it written? What does it say? And what was it used for? And it begins by measuring. So this is me in the house of the principal. Why are we doing the experiments in the house of the principal? Well, actually, this was what happened. So once the stone was cleaned, the principal, Ma'am Almodal, decided to put it in a pedestal in front of the school to give it the importance it deserved. She created a concrete. She had a concrete stand or pedestal made in front of the school, and she had the stone placed on that. And every day, going from work, for going from her house to her school, she would carry photocopies of the stone, and she traveled by public transport. And in that public transport, in a van, no, there were other people, her neighbors or other people riding the van, public transportation. She will distribute these photocopies and tell the story about the stone. So, like, she was educating the people in the van about, hey, we found a stone in this in our school, and this is very important because this has our ancient writing. So she was doing that almost every day, coming from work, coming from school, coming from home to school, and she was promoting the, hey, look, we have an artifact, an important artifact right here in our school. But one day, one of her neighbors said, Ma'am, there is a rumor that the stone has gold inside. Then she heard another rumor. Ma'am, there were people saying that at night the stone shines. But she was more worried about the first rumor that there was gold inside the stone, because she feared that if people believed that rumor, they might steal the stone and cut it in half and destroy the artifact. So immediately when she heard about the rumors, she removed the stone from the pedestal and kept it in her house for safekeeping. And that was why we found the stone in her house. And that was why we performed the 3D imaging in her house. I needed a black environment, so we waited until midnight to do this. So it was midnight when we did this. Okay, there was just a just light from the projector, but of course there was a flash because somebody took a picture of me while I was taking a picture of stone, calibration card, etc. This is our old laptop. We're doing this. Actually, when we went to this place, because there was already media interest, TV company came with me. So there was a media company that came with us and started filming us as we were doing research on the stone. Okay, all right. So here I was showing them the initial results of the 3D that we got. This is an anthropology graduate student who was explaining what the message was about, or rather what the symbol was about. And these are the media crew. And here's an example of one of the symbols that we 3D'd. The nice thing about 3D is that you can virtually play with the light source. You can put light source anywhere so that you can elucidate the carving marks to make it more pronounced. You can also rotate, virtually rotate, to examine the carvings. And this is already calibrated in terms of depth. So this is in millimeters. This is color coded. So here's one of the contentious symbol. This is the symbol nga. But if there is a cross below it, it becomes nang. So nga but once you see a cross, it can become a nang. So I was asked, is that really a cross or just a rock indentation? Not a carving, but a rock indentation. So we had several samples of nga in the rock and tried to view it there. And this was featured by the company that came with us is a media company, and they made a video about this and they posted it in YouTube. So the program is called Eyewitness by Javi Severino. Itinaga sa bato means carved on stone. Okay, that is the translation of carved on stone. Is bato also, what is Malaysian for rock?
It's a batu. Batu. So in Malay we call it batu, and in Philippines it's bato. So it's
Bato. Yeah, thank you. So tinaga sa bato means carved on rock. Okay, so there is this episode in Eyewitness YouTube, so you can have a look at that. And this is where so anyway, have a look. Kindly search for this on YouTube video, and you can see the whole video that they produced. And our result here was published in a book, but it was published just recently in 2017 by UP Press. Okay, so our research is published in this book. Okay. Now, another project that we did is now cartography of old informs the new, or this is COIN. Now, we have been experiencing extreme weather conditions, right? And we actually had a typhoon, it's called Haiyan internationally, which hit our country. And this was the first time we have experienced 300 kilometers per hour winds. And it was so terrible, so terrible. Even before that terrible typhoon, we already had extreme flooding conditions in the city. Okay? Several extreme flooding. Okay? So this project was actually inspired by these extreme weather events. Cartography, meaning the practice of making maps. Okay, so in our possession, because of our work on art, I've had a collaborator from Japan donate a scanner, a digital scanner, which is purpose made for paintings or other 2D heritage objects. So anything precious, brittle, or cannot be moved, or something like paintings, for example, can be digitally scanned using this technique and using this machine. This was actually developed by a Filipino PhD student in Kyoto University. His advisor does digital archiving. So he developed all these machines, and they donated one machine to us. And what we have done is pro bono for all museums. We offer our service to scan their paintings if they need it. And so we have gone, we are always, we usually get asked by the National Museum of the Philippines to scan paintings. For example, at one time, we were even part of the exhibit. Here we are in one gallery where we set up the scanner. It's called NIJI-S. NIJI is rainbow in Japanese. Okay. And we are scanning a painting by a national artist again. His name is H.R. Ocampo. And here are my students. And people are going around and then asking us, what are you doing? So we were part of the exhibit because we were explaining to the public, oh, we are scanning paintings for archiving. Now, how about old maps? So if you imagine old maps, you know, in Philippine history, we were occupied by the Spaniards back starting 1500s, no? And so they brought along their cartographers. they created maps of their establishments. And these maps back in the 1800s, 1500s, 1700s, 1600s, of course, they are hand drawn because there was no GPS or no airplane before. Of course, they had to imagine how it looks like from top view, given information from side view. So they had a lot of skill to do this. Imagine doing this for the whole archipelago. And so when you think about historical maps, they might not be as accurate as current Google Maps, but this is our hypothesis. Fresh bodies of water. If you are in a certain place, what you would need is something to drink. Fresh water, right? It's a very important resource, especially if you're coming to a new place. You need something to drink. Of course, you need some food, but you also need something to drink, and you need sources of fresh water. And so, even if the maps are not as accurate as current Google Maps, the places where the fresh water would be should probably be right, or probably they'll get it right, right? Approximately right. Again, as I said, this project got inspired, or rather was motivated by several flooding incidents in Metro Manila, in the capital, and also in the rest of the country. We thought, what if back in those days, there were actually rivers? In fact, one case in our country, there was a subdivision or a residential area which was totally flooded. And the scientists said, no wonder it is flooded. You are beside a river, and that place where the houses are erected, this used to be a flood plain. Flood plain. Okay. So if you build, so we thought, okay, if you build structures in former waterways or places where there used to be water, that's dangerous, because if the rains are so strong, the water will once again flow through these old waterways. So we said, what if we look at historical maps, those that were hand drawn, and compare it with Google Maps and try to align them and see if there are old bodies of water that have vanished in the present. Therefore, we can check if these are hazard areas. We can say that, okay, this could be a hazardous area to build a building. Okay? We consulted our Philippine Institute of Volcanology and Seismology to ask about our idea, and they said, in fact, rivers, or rather, for example, if you build on top of waterways, say for example, old river beds, their soil is sediment, no? They are fine sediments. And if there is an earthquake that happens, the place is prone to what is known as liquefaction. It's like the soil will become like quicksand if there's a strong earthquake in that place. And any structure placed on top of an old river, because of liquefaction, it can sink, it can topple, okay? It can be inundated with water. So we said, okay, it's an important thing to know where the lost waterways were. So here's an example of one of the old maps, Spanish era maps that we found in our national archives. We went to our national archives and asked if they have historical maps. And one of the maps that they showed us was this. This is in Cebu City. It's in the south of the Philippines. We only can do it for maps with roads because we will use the roads to align it to Google Earth. Fortunately, these roads are still here. Some of them have the same names despite being 400 years old. So the roads are the ones that we use to align the Google Earth map and the old historical map. And so here are my staff and students scanning the maps in the National Archives. Example here. This is an 1898 map of Manila. This is known as Pasig River. And Pasig River has a lot of estuaries. This symbol means these are rice fields. So these places used to be rice fields. No wonder, because the river can irrigate these places. So that's why people put rice fields there. Now, this is a 2015 Google map of the same place. As you can see, only some of the estuaries are still there. And the rice fields, there used to be rice fields, there are now some places, some structures there. We can do image processing to eliminate everything but the waterways, and we can overlay these images to figure out which parts have been added, or rather there are new parts there, or parts that have vanished. So we can do that using image processing. And we did that for several cities. And what we found was not only Spanish era maps, but also American era maps, because when World War II came, so the Japanese occupied the Philippines, but the Americans came and liberated the Philippines. And so the US Army created maps of Philippine cities. We found interesting maps, like this is the place where Typhoon Haiyan destroyed the city of Tacloban. So this is Tacloban City. We found the 1944 map, and it showed that the center of the city used to be, it looks like a lagoon, an old lagoon full of water. And there was reclamation around here. Again, as you can see, we can align this map with Google Map because the roads are still there. And we use the roads as alignment or ground control points. So this was fascinating because every time we did this, I send my staff and students to go to these places and investigate and really do fieldwork to check if indeed there are traces still of these waterways. So my students went to this place in Tacloban, and they asked around, they interviewed the people, they also interviewed the local government officials. They couldn't find any trace of this old lagoon. So they were wondering, how can we validate that there used to be a lagoon in this place? So being tired for walking around so long, they decided to eat at a restaurant. And while we're there ordering food in that restaurant near the city center, one of my students looked up and saw a picture frame. Oh, by the way, there are several other samples here. Just so, where is that picture? There's another picture here that shows the river in another city that has changed direction. And in fact, the government actually changed totally the direction of this river and reclaimed this area. So this is the natural meander of the river, but the current now has establishments here, and the river was redirected in a different direction. Okay, but what I was saying earlier about this image was that when my students were eating in that restaurant and they look up and they saw a picture frame, they saw an aerial photograph of this place. And indeed, in that aerial photograph, they saw a lagoon. 1940s aerial photograph, and they indeed saw a lagoon. So they took a picture of the picture and said, "Ma'am, this is the proof that indeed there used to be a lagoon in the middle of Tacloban City." Now, here's another example. These are two maps of Cebu City. I don't know if some of you have been to Cebu City. 1833, it looked like this. This is the sea, and there's an opening here to the sea, and then there are estuaries, okay, or canals. 40 years later, 1873, this is another map, and it seems that the land has closed up, and there's a lagoon in this place. All right, there's still the estuary, and there's a small, I don't know, there's a marsh here, and there's still that estuary there. And now, this is a 2015 map. You no longer see the estuary. I know you no longer see this lagoon here. It's no longer there, but the estuaries are still there, and area here was reclaimed. So this is reclamation land. Okay. So fortunately, I was in Cebu City when we already had this information. So I said, okay, I will do the field work myself. Okay. So I went to this place. This is where the lagoon was supposed to be. This is a screenshot of my mobile phone when I was trying to figure out how to get there. And the satellite image shows that there are many houses here. So I walked towards this place and I saw that first, okay, there is a canal. There is a canal on the side. And apparently, in the Google map, I was actually walking around this place. No, I was walking this way, and then I saw this canal going this way. And I said, okay, this part is still present. Perhaps this one, this waterway is still present. It's just not seen in Google Earth now. But apparently it's still there. The canal is still there, although very polluted. And now this is the middle of that place where the lagoon should be. And what I see, of course, there are houses both sides. And I saw this sort of canal structure on the road. I interviewed the residents who live there and I asked, does it flood here? And they said, very often. This was March 2015, by the way. How often does it flood? Well, the last flooding was February, they said. So I continued walking, trying to look for signs of the lagoon that used to be there. And then I reached the end of the road and I saw this sign, Barangay Disaster Control Office. How ironic, I said. And there were 3-story buildings here. Okay, I said, which of these is the Barangay Disaster Control Office? So we looked around. And over here, I saw people wearing the same T-shirt. And I asked them, excuse me, may I ask, where is the disaster control office? And where is the barangay disaster control office? And they said, we are the barangay. So when I learned that, may I give a presentation? I said. So I put out my laptop. I showed them the maps that I showed you, the ones that we aligned, and I told them that this used to be, your place used to have a lagoon. Okay, and our Institute of Volcanology said there is danger of flooding here and danger of liquefaction. In fact, they even told me na the PBOX also told me na there shouldn't be any tall structures when the place is old waterway, but there are 3D structures here. So what can you do, no? And so these are them wearing the same colored T-shirt. When I was telling them about the place being an old lagoon, by the way, this was their captain and these are councilors. This lady said, "Oh, my grandmother used to say that when she was a young girl, they washed their clothes here." So that was a validation that this place used to be a lagoon. So I told them that please be careful. If there's an earthquake, please run out of this place because there could be a liquefaction. At least I've done my part and told them the results of our research. This research actually was featured in SciDevNet. No? So if you take a look at December 18, 2018 issue, Old Maps Handy and Heading Off New Disasters, this work was featured in that online magazine. And lastly, I'd like to talk about a recent work that we finished during the pandemic. So this is the thesis of, again, this is physics, okay? But this is the master's thesis of my student, Mark Jeremy Narag. And we're using convolutional neural networks, discovering art influences of painters using CNN. Now, perhaps you've heard about convolutional neural networks in the context of what is known as style transfer. Have you seen this before? That a painting and another painting, you want to combine their styles. This is called style transfer. You can do this using convolutional neural network. Like this is the Mona Lisa in the style of Starry Night. And this is Mona Lisa in the style of giant waves. No? Okay. Now, the thing is, this has been, well, there are actually apps that you can do this even on your pictures, on your photographs, right? So we wanted to try something different because this is already common. We said, what if we can use convolutional neural network, which is the technique used here, to discover artistic influence. Because what is this is the style of one painter is transferred to another. What if, since the network can determine the style, what if we can elucidate from painting samples which artist was influenced by another artist? So we tried that idea. Fortunately, again, remember please, this research was done within the pandemic. Fortunately, we have WikiArt. This is a free page where you can download paintings by artists and different art movements. So we have samples of paintings. Okay? It's needed because in convolutional neural network, this is a very complicated a mathematical model of how the brain works from examples, and you have to have a large amount of examples. What we did was we tried to study painters from Expressionism, Impressionism, and Surrealism art movement to see if these artists, which artist influence which artist. Okay? In one case, what we did was, for example, have a look at these artists. We downloaded their paintings, okay, and we tried to classify using convolutional neural network and a neural network for classification. We tried to classify paintings done by them. So, for example, when you use a neural network, the reason why you have to have a lot of samples of paintings is because this is the collection of paintings done by that artist. You will separate them into two sets. One is the training set, in which you will train the neural network to realize that, okay, every time you see some kind of this kind of style of painting, this is done by Joan Miro, or this is done by Pablo Picasso, or this is done by Paul Delaunay. Okay, so this is the training set. Now, you will attempt to test the neural network if it is already trained using your test set. These sets have never before been seen by the neural network. These are novel examples. So you give it a painting, and the neural network will try to classify that according to one of the artists that you have trained it for. But what we realized, what we found out was there were certain artists that were always confused to be, or rather, there were certain paintings that were always confused to be done by a different artist. Take a look at this painting by Joan Miro. It was always classified as something done by Pablo Picasso. And how about this work by Salvador Dali? It was misclassified as something done by Rene Magritte or Sidislav Beksinski. It was assumed to be done by Max Ernst. Whatever architecture, convolutional neural network architecture we used, it was always misclassified, which is why we thought maybe the reason why the network got confused is because these artists influenced each other. So when you say artistic influence, you mean the style of one artist was influenced by the style of another artist. And usually art historians theorize or discuss who influenced who. So we found a way, an objective way of maybe finding out which artist influenced who using this confusion matrix, using a network that is confused by, okay, I thought this was made by Pablo Picasso, so I will score it as Pablo Picasso, only to find that it's a different artist. Using this information, we got this kind of influence network. So again, Expressionism, Impressionism, Surrealism. For example, in Expressionism, this is what we found. These lines here are the connections found by the network. We didn't do anything. We just trained the network using several paintings of each of these artists in this art movement and let it classify. And from the misclassification, we connected the dots. It turns out when we dug deeper, we found that, for example, here, Ernest Ludwig Kirchner and Otto Müller had a strong connection because they went to the same art school, they are from the same country, and in the technique that I will tell in another in the next slide, it is also established that the paintings of these two artists get confused by the network. Have another look at this Impressionism. So the network itself created this network of influence of artists. We didn't do anything. We just trained the network and look at the confusion matrix. And it created this network of influence. And Claude Monet and Alfred Sisley had a connection. And when we researched further, we found that they are friends. They are from the same country. And there are textbooks that say they indeed claim artistic influence with one another. Once again, another technique that we used also shows this, okay? And so on and so on. So Pablo Picasso and Joan Miro, no, they get confused by the network, no? It's because one reason is they are from the same country, and that makes sense, no? You tend to copy the work of artists of your from the same country. But there are connections that there are no texts or papers or books that tell their influence. And so what is nice about this is that we can investigate. This can be further investigated for future study to see if indeed they actually influenced one another. So it keeps the conversation going because not only are these popular artists now established to have influence, but because of this network, blindly, it was able to classify which artist could have influenced another. Okay. Now, we actually tried another technique, once again using neural networks. And this is, have a look at the power of a convolutional network. Once trained, no, you can ask it to, okay, look for paintings that look like this. And from the collection of paintings that you show it, it will say, okay, this painting looked like that. And indeed, have a look at that. No? The convolutional neural network was able to bring out from this collection, massive collection of paintings, paintings that exactly, rather looked like this search painting. Again, Eugene Boran. Here's the painting, and have a look at what the convolutional neural network got out. Also Edward Wadsworth. Look, this was what was retrieved. We once again use this ability of a convolutional neural network to retrieve similar looking paintings to create networks, okay? Networks of similar looking paintings by artists. And when we had a look at the artists' names, this was what happened. So for the Expressionism art movement, we had several artists. I'm sorry, this is very small now, but these are names of artists. But the larger the letters, that means it has more, they are a hub, they are very big influencers. And you see this is a network, so there are nodes and there are edges or connections. So as you can see here, this is how the network of expressionist painters seem to be connected based on the similarities of their paintings. What's amazing here is have a look at Impressionism. So once again, this was just made by the network. Okay, Claude Monet, Auguste Renoir, Edgar Degas. It says actually in books, Claude Monet, they say, is the father of Impressionism. And indeed, it seems, look here, the convolutional neural network itself was able to establish that indeed, lots of influence from Claude Monet and Pierre Renoir and Edward Degas. Okay? And also Surrealism. Look, major here is Salvador Dali and all the rest of the other painters emanating from this network, Pablo Picasso, and all the rest that they seem to have influence. So some of these actually have been established that they're influenced, but some are not. So what this technique shows us is that, there is clue as to who could possibly have influenced one artist in his artwork, in his or her art. And in fact, this paper was published just this year in the Journal of Cultural Heritage. Okay. And I'm proud to say that even during the pandemic, we were able to do this thanks to WikiArt and open source software from Google Colab. So even if my student was, because of community quarantine, he had to go back to his home province and we had research meetings online, he was able to perform the calculations because thanks to WikiArt, which is free, open access, and also Google Colab, which is also open access and free. Okay, so those are the research that we have done. This ends my presentation. I thank you very much for your attention. Should you have any questions, this is my email, and I welcome your questions or inquiries by email. Thank you very much for your attention.
Thank you very much, Dr. Mariko. This is a very good talk. Okay. So before I open for Q&A session, okay, I would like to maybe make some summarization from your talk. Okay. So what we can see in Dr. Mariko's talk today, there's 4 things to be learned. The first one is the digital restoration painting technique. Okay. And well, it's a bit more similar to what people done in NCIS or CSI, just investigate the painting or the blah blah blah. Again, and it kind of remind me the movie. Sorry, okay, it kind of remind me a movie of National Treasure where they try to preserve the painting or that. But in your work, Dr. Mariko is doing a digital painting conservation. Okay, and then we also have this. Dr. Michael also tell us about the 3D digitalization, which involve the batu, okay, the carved stones there, and it reminds us that we also have this carved stone here in Malaysia, where the famous carved stone in Terengganu. We call it batu bersurat Terengganu. We will also have that as well, but I'm not sure if the story is quite the same as yours. Your story even got some funny thing there, because that stone had been found by the principal, and she asked the student to rub his foot on the stone. Okay, so which I think, wow, that's bad. Okay, you should not do that because that stone is very it's priceless because they have the heritage conservation over there, the Babian writings. Okay, so the third one is about the cartography. Is something to do with scanning the maps. Okay, and it's quite interesting to know about this because it's related back to how the country should develop the areas. Okay, so if the area is supposedly to be lagoon, or if the area is supposed to be to have a big source of water, so maybe it's not a good idea to put a building on top of it. It can topple anytime, especially Philippines. They always have this natural disaster, sometimes earthquake and some not. So it's very risky. It's very risky to put something routines something like that on the lagoons, on the spot of the lagoon. Okay, which is remind me as well, which what happened in we have that as well in Penang. For example, the Fort Cornwallis, the heritage site in Penang where supposedly the Portuguese come here and they put the wall. Okay, well, if you look at the historical line, actually the Fort Cornwallis itself has certain area where it's a water coming from the sea, and now, okay, after after a few years, after a decades, after 100 years later, that area has been reclaimed by maybe the government put the soil there, so there's no river at all. But then again, when understand that is how risk to have the big building on the top of that, well, it's something that we have to consider about it. Okay, the last one is the artistic it's CNN analysis. I would say that CNN analysis, where it helps you to investigate the style of the artist. Okay, so for example, like you said, how Pablo Picasso has influenced another artist. Okay, how their style is actually quite pretty similar. So we have to trace that into the time, and we have to trace that to the style of the painting itself. It's very interesting to look at how they how they learn from each other. Actually, I would say that because nowadays, if you're looking at the fine artists, they also have a gist of influence to one to another. Okay, if they want to learn from this artist, they still just a tiny bit of similarity for them, which is nice to look at it. Okay, so I think that's all my summarization. I'm not really a fine artist, but this is very interesting to listen to. So now I'm open for the Q&A session. I hope that anyone here who have any questions, you can unmute your mic and open your video, and you can straightforward, should ask Dr. Marco anything that you want, or if you're a bit shy, maybe, so you just write your question on the chat board there, and I will read them for you.
Okay, Dr. Jamil, may I?
Yeah, sure. Carry on, Prof.
Okay. Okay, Dr. Mariko, thank you very much. Awesome.
You're welcome. Thank you.
Also send my regards to your wonderful students. I think most of, probably all the projects that we have shared shows how passionate you are as a professor, as a lecturer, as a supervisor of your students. I can sense that in the way you present what all the projects that have been done. My curiosity is what kind of response that you get from the end users, the potential end users, like in the case of the CNN, what kind of response that you get from art historians? Did they say anything? Do they like it, or they don't like it, or they despise it, or they see the potential to either affirm whatever a particular kind of theory, or to dispute, or to create new hypotheses? Very interesting in the way you use the AI system. What do you call it? Since CNN.
CNN.
So I'm curious. Did you receive any? People like our friend Patrick Flores. Did you show to him? Did he say anything about it?
Okay. Actually, I invited them to the thesis defense of my students, so they can see what is it all about. Some asked for copies of the thesis, but now we have a paper, so we gave them copies of the paper. Now, I think there would be more reactions if this was done on Filipino artists. We actually tried. But you see, this technique will require a large number of paintings. Large number. We're talking thousands of paintings. And there are artists that have been very late in their lifetime that they have indeed hundreds or thousands of paintings. Unfortunately, we're not there yet in the Philippines. For example, we would want to do this for Fernando Amorsolo, but we do not have enough scanned paintings of him yet, or other artists in the Philippines. So much as we want to do it for local artists, perhaps it's not enough. But we have done it. We have done the first technique, the one that uses what is known as a confusion matrix. We actually have tested it on an artist named Juan Luna to check if we can classify his paintings. Classification only, not confusion. So we have tried applying this, but it's only partial. Because unlike
Mm.
in wiki art, unlike in expressionism, surrealism, neo-impressionism, all those art movements, they have a large collection of painters' digitized paintings, especially European painters, and
Mm.
online. So we don't have that
So
yet.
so
If we
so
have some,
basically it requires massive data. Is that correct?
absolutely correct. That is what is
Okay.
actually required by
Okay.
CNN, massive amounts of data.
Yeah. If not, probably it's just a waste of time. Okay. All right. I can understand that. Will be interesting because I see a lot of potentials in that. It's very interesting to see how that can be used to either create new hypotheses or to create or to affirm a particular theory. But again, as you say, it requires massive data in order for it to be used. Anyway, that is very interesting lah. So that's the only question from me. Thank you very much for sharing. Wonderful. Hopefully, to I can see you in Penang again with your students.
Yes, hopefully, hopefully.
All right, Dr. Mariko, I do have one question for you. So we're actually not one question. I have a lot of questions here, but I just want to be fair with the audience. But for now, just let me be the second person to ask you the question. Okay, I'm going to ask you the question stage by stage because you have this like four category, digital restoration painting, digital 3D digitalization, and cartography, and then and analysis. So the first one about the digital painting restoration, I was wondering, okay, along your work, along your career when you're doing the digital painting restoration, have you encountered a situation where you found these two painting? One is the original painting, and another one is the fake painting. So I was wondering, uh, how do you study on both painting if you encounter them, because the painting supposedly have this texture, this a very significant texture, is very different color and all that. So how actually can we, what do you think about fake painting? What can you tell us about the fake painting? Thank you.
Okay. I have two things to say about that, encountering fake paintings. There was once a time that the National Museum asked us to investigate a painting done by one of our national artists, H.R. Ocampo, because there had been found several paintings which are being sold and which were being attributed to the national artist. But there were doubts. There were doubts. No? So it's like all of a sudden, a lot of paintings attributed to this artist came out and now they were being sold. And so several art experts said, wait a minute, that doesn't, there's something fishy about these paintings. They seem to be fake. They had their doubts because they've studied the artist, they know the artist, and they see some traces of fakeness in those paintings. And so the National Museum asked us if we can be more objective and see if we can do that. Now, what happened was, so we were able to take a picture of original paintings by that artist, but the problem was we were not able to access the fake paintings. And that was so very much needed. You can do chemical analysis to do, because there are other techniques to investigate if a painting is um, is made indeed by the hand of this artist. One of which is chemical analysis. However, since this is a modern painting, so the paints can be of the same origin or the same, it can easily be said that these paints come from the same age. Okay. So we tried to do image processing to see if we can find some statistics that can say that this painting is dissimilar or different from uh, the purported artist. And our problem was we have not enough samples of the fake paintings. And you know why? It turns out all around the world, the same is happening. If you are a collector and you happen to have a fake Pablo Picasso or a fake Pollock, what would you do if somebody or some scientist will tell you, I'm sorry, but your painting is fake. You know what people will usually do? They will sue the scientist. They will charge the scientist. And it has happened before. And it has happened actually to a group of physicists. Okay, when they said that the paintings, certain owners with the Pollock paintings actually seem to have a fake Pollock. They were vindicated, by the way. Indeed, the paintings sold to those collectors were fake. But the thing is, what's the problem with this technique of image processing is that you need samples of fake paintings as well, and known fakes or established fakes. And no one would surrender fake paintings because of the repercussions to their person or to their agency. If you are a gallery who has a collection of paintings and it was found that these are fake, what would happen to the reputation of your gallery? In fact, the gallery owner of said paintings wanted to sue the National Museum. Do you understand? So it was difficult at the start because we did not have enough samples of the fake paintings. However, do you know in Europe, they actually have a collection of fake paintings that are known to be fake, and yet they collect it for study. Peter Bruegel, for example, there are many people who tried to copy Peter Bruegel. So they have a collection of fake Bruegel paintings. So that's all right. They collected that. And in fact, there were many papers that came out of that research because they have the samples. So the first thing that I like to say is image processing based authentication of paintings is difficult if you do not have, how do you call this? Authentic fakes, real fakes, real established fakes that are that you can study. So that's it. The fakes are with fake. For example, fake Amor Solo. No one would surrender their fake Amor Solo because they wouldn't be able to sell it anymore. It will ruin their reputation, etc. So that's the first. The second is again the data that is needed. Well, actually, that's the first and the second now. For example, Amor Solo is known to copy his paintings. So he has made several copies of a painting. I think one of which is the title is roughly Woman Cooking by the Fire or Rice Planting. So he made several copies of his paintings because several of his clients want the same painting. Okay, wants the same copy of the painting. So he made several. And so the thing is, he was easily copied by other artists who passed them off as fake. So if there are artists that did copy themselves, it becomes a little bit harder because first you have to establish which are the actual copies. And if there is no record or trace of provenance, this is going to be hard. Okay? So the ability to authenticate rests on the quality of the data that you actually have. Okay? There. So
But thank you. That's very interesting. But I am very fascinated with the when you claim that this the Amor Solo is replicate his own painting.
yes.
Exactly the same. Yes. Is it exactly the same? Meaning that if he produced 5, if he replicate his painting to 5 set of painting, so all that 5 is exactly the same.
Not you know, not 1:1 identical, but you see it's the same theme, it's the same appearance. So if you put them side by side, of course they're not carbon copies of each other, but you see that they are similar in appearance.
So how about the fake painting? I mean, let's say we have this Picasso original painting and we have this fake painting that we got it from black market whatever. So these two are identical. You know, there must be a case where these two are very identical. So how the forger do it? Do you have any idea how they do it?
Yes, there usually are authentication boards by each country should probably have an authentication board. And usually these authentication boards are peopled by scholars who are learned about the style of the artist or who have studied the artist. There are authenticators actually, and they give certificates of authentication. For example, Amor Solo, one of his authenticators is his daughter, Silvia Amor Solo Lasso, because she was a painter also, and she was with her father when when he was painting some of his artworks. So she knows from memory what the paintings her father did, and she is also an artist herself. So she can write a certificate of authentication claiming, okay, this is the painting. All right. Some other scientific ways of finding out if the painting is really done in this is through the material analysis of the pigments or the samples. And however, this is more typical of century-old paintings because we know that certain pigments were not invented yet during a certain era. No? They came out just recently, or during this age, this kind of pigment was the one that was used during that time. So by pigment analysis, one can figure out chemically if this pigment actually did exist back in those days, or this is a new pigment. We can do that for century-old paintings. It's more difficult for paintings within the same era because the same sample or the same pigment or medium can be used within the same era. So yeah, there are chemical scientific ways of doing this. The one is chemical, right? But the other one is by history, material and personal and even economic history of the artist, by knowing that.
Thank you very much, Dr. Mariko. So I'm going to open the platform for our audience. If you have any question, please unmute your mic and maybe switch on your camera and ask your question.
Hello. Hi.
Yeah. Hello. Yes.
You can hear me? Okay. My name Laila. Hi, Dr. Mariko. Did you remember me? Okay,
Oh,
I
yes.
have a question about actually you're talking about the art or the art scene, but my interest more on the forensic that you tell the first slide, right? What kind of research that you done with the forensics department? Maybe you can tell us about that.
Okay. All right.
Thank you.
Well, so this is not art. This is forensics already, right? So we've done a bit of research there. For example, we given a CCTV footage of a car because we wanted to see if can we establish what has happened to a car after a collision, or can we trace, for example, a car hit somebody and ran away, but it was caught on CCTV. Can we read a license plate, even if it's blurred or small? So we had the research there how to resolve the license plate of moving cars. That was one. Our recent work is on blood splatter analysis. You can determine where the blood source comes from the pattern of the stain. So there is a technique there. So this is image processing. You can establish just from the pattern of the blood droplet where the source could be. So those are the two things that we have done on forensics so far.
Did you use the same technique as you use at the art side, or
Very different. Very
Oh,
different.
different.
So for super resolution, we needed, but we used video. From super resolution, video is needed. So from several video of blurred images of a car moving away, we can actually reconstruct the license plate, even if it's blurry. Right? From blood splatter analysis, there was a lot of physics there that we had to and fluid dynamics that came in the analysis to determine, okay, what are the transient and steady state response of a blood droplet, how we can determine the velocity of the blood just from from looking at the stain or from the video of a blood dropping on a surface. So different techniques. We use different techniques for this, but still using image and video processing.
Okay, thank you.
All right,
welcome.
thank you. That's a question from Laila. So anybody have a question? I mean, student, do you have any question? If you have a problem to convey your question in English, maybe you can just speak it in Malay or first, and then I will try my best to translate them for you. Or you can just write it down at the chat box. Please, students, this is your chance to talk with the experts here. It's a very, this is very wonderful opportunity for you to get know better and talk with the experts. Come on. Anybody got any questions?
They are shy. Don't be shy. Come on, you can ask it.
Okay.
Hello.
Okay,
Hello,
good.
morning.
Yeah, good morning.
Nizam ya. Okay. Clear. Betul. Dia
Yeah,
clear.
yeah, we can hear you.
Okay. My question is, since there is a lot of students here, what is your advice to them if they are interested in your direction, or maybe how to develop their background?
Okay. May I know the students? What are their courses? May I know that?
If I'm not mistaken, we got fine art student. I think it's actually because professional said here that most of them are taking the BRA 101 classes. It's a very fundamental classes, and I think it involves all the students at the School of the Arts. So I guess they have fine arts.
Not fine art students. We don't have fine art. I don't teach fine art students. The students, no fine art students. The students are from new media technology, new media design and technology, from product design, and also from graphic communication. When it comes to image processing, I think that has to do with predominantly with the new media students because they can relate that to what they are doing, because it has to do with their own what do you call it, their own field as well. Of course, Dr. Mariko's approach is more into the technical part. I'm not sure about the fine art students, but my students are all from these three different departments, and they are first year, so they might be first year, first semester, first 2 weeks. So they just received, as far as from my class is concerned, about creativity. So in creativity, we learn about the need to converge both the left and right brain, how we can use this whole brain system, how we should encourage the synergy between the sciences and also the arts, and also we are also translating that through our research unit, which actually is headed by Dr. Jamil himself under the Muzium and Galeri Tuanku Fauziah. We call it TRAS. It stands for apa, Dr. Jamil?
Transdisciplinary and sustainability in art science research unit.
Yeah. And I'm also a part of this art science initiative, National Art Science Initiative, which we have been doing since the late 1990s. So actually, it's a very what we call it, challenging venture, and I have been engaged in it. But I don't want to tell my story. Maybe Dr. Mariko can share her side of her story in engaging with this art science research through the research works of her students, and how students taking artistic disciplines should expand also their understanding and engagement with fields outside the comfort zone of their own particular discipline. Because in the reality, we need to merge both the arts and sciences, as some of the examples of projects done by Dr. Mariko's students have shown. So maybe Dr. Mariko can share with my students what is the importance of engaging in both the arts and sciences, and what you can contribute from there. Maybe that can be helpful.
Right. Please remember that I am a physicist and I'm doing physics, and I'm doing something in art. And and perhaps you can also this was my very first major project, this project with art. And what I learned at the start of my art science career was this. In that project, we had museum researchers and we had engineers in our team. And during the times that when we were having research meetings, at the start, I was looking at the museum researchers and they were frowning when we were discussing, the engineers and I were discussing, and my team, my physics students and I and the engineers were discussing, the engineers and my students, and we were understanding each other. But the museum researchers were a bit frowning and a bit, there's a question mark on their faces. That was the start. But as we continue doing this project, one time when I look at them, they were smiling. And I asked, why are you smiling? Because one of them said, I now understand what they're talking about. I really, really understand what they're talking about. But that was not only true for them understanding the science and engineering, it was also true for us. Because engaging with other disciplines is like learning a new language and learning new ways of thinking of things or looking at things. And it was so enriching for me personally and for my students to learn about impasto, chiaroscuro, and all those art techniques, provenance. So we not only taught them, we also learned from them. And so what I want to tell everybody here is that open your minds to, or be open and receptive to ideas from other disciplines, because this could enrich and even inform your own work as it had mine. So be open to other disciplines and be open to other ideas. Try to explore other disciplines, very polar opposite from yours, and you will be very enriched. I have learned several new words because of my work in art. I have made several new friends. Of course, Professor Hasnul is part of them, and Laila also. Very long time friends, very good network. Okay, so you will make new friends, you will learn new languages, the language of art, the language of art appreciation. How about you? Perhaps you would learn quantum mechanics or something that you can use, in quantum computing. That's the future of computers.
My name is Harani Kapsa binti Harun. I'm from product design and I don't have any background about arts. I will talk about cultural perspective, but first I will talk about my personal perspective. From my own perspective, this video is that I have it was unique and I feel happy when I watch it. And it has a patriotic spirit. Culture is shared understanding the image from shared experience. This helps people to get along and enjoy a sense of common identity. Cultures exist at any level, such as a national culture.
Yeah.
Well, yeah, thank you very much.
She actually tried to ask a question, but there I think it's a program. It's a voice program, I think. Something like that.
Tak boleh. Satu kat Jaipan ni tak boleh.
Apa lagi tu? Everyone has been mute. But then again, just now, there's one. I think a student she tried to pose a question, but I think she's using the voice programmer or something like that. So that's why the question keep coming like that. So it's kind of confusing and interrupt what Dr. Marco is trying to explain. Sorry for that, Dr. Marco.
No worries. No concern. But yeah, that's the point. Just be open to other ideas, especially those that are polar opposite from your discipline, and you will be enriched by it. Yes, that's the
Yeah,
idea.
I agree. I have two physicist friends. One is Dr. Chung. He's into astronomy. Another one is Dr. Mazlan Osman. And physics, I failed physics during my school time. I hate mathematics, additional mathematics, calculus, not good at it. I fear that physics very much. I didn't like it when I was a student. But then when I met Dr. Chong and Dr. Mazlan, I became like a new kid. I became like a excited kid because I'm learning something new about the sky, about the stars, and when it comes to Datuk Mazlan about quantum physics. Quantum physics is another is extremely interesting field to discover a lot about our beingness. So yeah, I agree with Dr. Moriko. We brave ourselves to know about anything, even things that are at the polar or the opposite side of our discipline, and that will make us not only give us more, allow us to have new friends, but also most importantly new knowledge, and perhaps can help us to become a better person. So I do agree with that so much. Anyway, I'm curious what was the question by the student, because it will be interesting if we can ascertain what she was trying to ask.
Yeah, her name is Karani Kapsha. I think, Miss Karani, do you have the question? I think you have to play that.
Boleh cakap dalam bahasa Melayu. Kalau tak pandai boleh cakap Melayu, kita translate lah.
Yeah.
Yeah. Tak apa, you boleh cakap Melayu. You can speak in Malay if you want to. We can translate for you. Don't worry.
Siapa-siapa nak cakap dalam bahasa Melayu, silakan. Kami akan cuba untuk translate dalam bahasa Inggeris. Yeah.
Don't worry. This is a learning process. It's not a ranking or apa orang tu viva. No. So kalau nak tanya bahasa Melayu, okay, boleh tanya. You can ask in Malay as well. Dr. Jamil can help to translate. Anybody? Karani lah.
Karani tadi dia. Hello, Cik Karani. Ada soalan ke?
Dia dah hilang.
She's still here. Cik Karani ada soalan ke? Boleh ajukan soalan. Oh, siapa-siapa yang ada soalan, silakan. Dalam bahasa Melayu, silakan. Kami akan cuba translate.
Oh, you have any opinion? Ada pandangan? Kan? Not everybody likes this idea of converging the arts and sciences. So we have to also allow that people who to share that also.
Yep.
Yeah.
Okay, anyone? Anything to say? Anything to ask, please? Both in English or in
hello,
Malay.
good morning.
Yeah, good morning.
Hello, good morning. This is Perry from the Philippines.
All right, Perry.
Mom, Mom, good morning.
Morning. Hello.
Hi, Mom. I just have one question about CNN. Mom, you mentioned that you need thousands of paintings or data for the CNN to work. Do you have a ballpark figure, Mom, of the number of data on the minimum number of paintings that you need?
Yes, there is actually a rule of thumb. Anytime you make a network, there are actually what are known as free parameters, meaning those parameters that you have to estimate. These are also known as weights. So essentially, the rule of thumb, simply put, is like this. You can determine how many free parameters you have based on the network design. Okay. And at the minimum, it's like how many equations, how many unknowns how many equations do you need to estimate the unknowns, di ba? If you know, in mathematics, if you have 3 unknowns, you need 3 equations to be able to solve the unknowns, right? So essentially, it's something like that. If you have n unknowns, you have to have a minimum of n equations. And so it is with CNN. The thing is, with CNN or neural networks, the order of the free parameters is in the thousands. So many connections, so many random weights that you have to estimate. And therefore, the needed number of data is also in the thousands. So that's the rule of thumb in neural network training. Neural network is just, CNN is just a very deep neural network. That's the answer.
Thank you very much, ma'am.
Welcome. Thank
you,
for
Mr.
being
Perry.
here.
Thank you, Mr. Perry, for the question. So anyone got more questions? Yes, I do have one more question to Dr. Mariko.
Yes, please.
Dr. Mariko, about the 3D digitalization of carved stone. You're saying that on the stone they have been carved with Babayan's language. Okay, so I might have miss her or lose it somehow, but does it say anything? Does it have complete phrases on the stone? What does it say actually?
Well, it only sees the surface of the stone. Yeah, there. If I understand correctly your question, are you asking what does it see?
What the because they have this language on the stone. Is that say something? I mean, on the
Yes.
stone.
Okay.
Yes.
Okay. I see. Okay. Now, actually, it is still undetermined what exactly the stone is saying, because it's like, let me show you an example. This is a newspaper. So here the newspaper has the newspaper has lines of text. Now imagine cutting the newspaper diagonally. So that was what happened to the stone. There is several lines of text, and the stone was fractured diagonally. That's why it looked like a triangle. And so it seems that the sentence may have been cut, no? Because it's easy, newspaper, you have lines of text. Imagine cutting, scissoring that diagonally, you will lose some of the words. However, there were some words there that were clearly there. For example, batahala. Bathala. You have same word there, batahala. Bathala.
Batahala, what it means?
Bathala in old Filipino is God.
Berhala.
Bathala, yeah. So, but when you read it, it is batahala. So when you read it fast, it's bathala. Do you have same word in Malay?
Well, if judging from your words, we have this berhala, but berhala is for statue or no, for many things like that.
Okay. Yes,
but berhala is related. But berhala is related to God for some people. For some religion, that berhala, I mean the statue, for them is a god. So
yes.
I don't know whether it's correct or not.
Okay, so the word batahala appeared several times in, I think, in both sides of the stone. There was the word, so it was clearly seen. There were 4 characters there that says batahala. There are also several words there repeating dai. Because this was found in Bicol region, in South, dai is either you say don't or do not. So it seems to us that, okay, there is God and there is do not. Perhaps this is 10 commandments written on a stone tablet. We don't know because it's incomplete. However, the small stone was already deciphered. So essentially, the big stone with so many Baybayin characters, there are speculations about what it says, but the sentence is incomplete because it was cut diagonally. It was fractured diagonally. So we don't know what is the content of the other half. But the small stone, because it has only few characters, it was already deciphered. So the hypothesis is the words that is written in the small stone is tahumanan nakatana. Does it mean anything in Malay? Tahumanan nakatana. So that was the word in the smaller stone. According to the experts that deciphered this in University of Philippines, tahum is a ritual for dead people. It's a ritual for people who have been killed. Tahum. So tahumanan means a place where the ritual is being done. So if somebody is killed, there is a ritual that is being done on the killed person, and tahumanan means the place where the ritual is performed. Nakatana could probably mean, they say, it is already reserved. So essentially, what the small stone is something like, beware, this is a place where killed criminals or killed people are ritually, there is this ritual for killed people here in this place. This is reserved. That is one hypothesis for the small stone. Tahumanan, nakatana, place where ritual for killed people is done. This is reserved. So that is what is meant. That is what's found in small stone. In large stone, what we are only sure is that there are several instances of batahala and dai. Okay.
Thank you very
And
much.
actually, we are opening this. This is still open to interpretation. So anybody can. The book actually it tells how to try and interpret the characters. So you can make your own hypothesis about what is written. Still open. Still open.
Okay, Dr. Mariko, thank you very much for the answer. It's very interesting to hear that. Okay, we got a question from Adina Khalid here. Hi, I'm Adina from Kota. Since your research involved a multidisciplinary team, can you kindly share with us what are the strategies or approaches applied during the discussion?
Thank you. That is a very good question. When you discuss with a potential collaborator from a different discipline, for example, I am talking to somebody from art. I am a scientist, but I'm talking to an artist. Number one is be humble. Never think that you are superior. Always think that they are your equals. Do not think that you are better than them. These artists, they are not logical. They are so subjective. Don't think that way because they have different ways of thinking of things and they have their own expertise. So do not think that you are superior to them. That is the number one thing that you should do if you will be engaging with people of other disciplines. Number two, always think that there is something interesting. I personally believe, and I've witnessed this several times in my research career, that the interesting science or research is in the interface of disciplines. This is physics, this is art, and what's interesting is the one in between. Okay? The interesting research could be in the interface or in the middle of these disciplines. Okay? Yeah, so those two. Be humble, be open, and think that the interesting research is in the interface of two disciplines. And
I
Thank you,
totally
Dr.
agree.
Mariko.
I totally agree with Dr. Mariko on that, because in the social sciences, there is even a theoretical proposition in regards to what they call or what they term as the in-between, because in-between are undefined. When we go to the extreme edge of our disciplines, we are not really at the center or at the comfort of the center of whatever discipline that we are in. That is where, of course, in that kind of a field, we are not sure yet, and when we are not sure, we may not be comfortable. But that's where we can discover a lot of new things that we were not aware of before. So I do really agree. And thank you, Dr. Mariko, for saying that. Please be humble. Very good reminder to scientists working with artists. There is always this kind of by default superiority complex among those who can use their left brain towards those who use their right brain more, like me. So I was considered in school as a stupid student uh, because I like art. So I don't think it's fair. It's just a different way of accessing and processing information and experiencing life. Actually, in actuality, we need to have both. So if you are lacking on the left brain like me, I will have friends like you to compliment me by being humble and look up to you as my sort of guru in regards to the sciences. I agree so much with what you have shared with us. I have Dr. Mariko. I am in the hotel. I need to go and catch my plane, so I have to leave. So I have to say thank you to you personally. We will probably do this again later. Hopefully, we can engage in in any kind of future research. You have here Dr. Jamil. Please keep in touch with Dr. Jamil. Dr. Jamil is in charge with our research unit. So bye-bye. Thank you to my students, everybody here. Thank you very much. I'm flying back to Penang. Bye-bye.
Okay, thank you, Professor. No, thank you, Dr. Mariko, for the answer, for saying that. Yes, I'm totally agree with you, with Dr. No. I'm also agree that when we're doing work, when we try to be integrated in different fields that work together, so the respect to other people, no matter how old they are, how young they are, how different they are from you. For God's sake, you are physician, you are physics expert in physics, but you are doing something to do with arts. Okay? So it's a normal in this current world today. We are being multidisciplinary and we try to respect everyone in our field. We try to achieve something for the better good of the people, for the better future. So yes, your question is spot on. Yes, respect people and be nice and just work together. That's it. Okay, I'm open the platform to maybe one more question before we can wrap up. We actually have gone for 2 hours right now. So anybody, do you have any question? Anyone, do you have any question? Please shoot your last question. I think this will be the last question, I hope.
Hi, me again. I do have a question. Okay, back to CNN. Okay, about the neural network. Okay, I just want to ask you: did you study about the colors? Okay, that the artists apply to the canvas, and what is different or similar to their influence or the big artists? Did
okay.
you understand what? All right. Okay.
Again, did we study the color? Did we?
Yeah.
Right. First of all, just a moment. May I call, if you can, Jem, apparently my student is here, the one who worked on this.
Oh,
Jem,
good.
is it possible for you to open your phone and speak? Yes,
Hello.
Hi, Jen.
here it is.
Hi,
So
Jen.
this is the student who did the work. So go ahead and answer the question. Again, did we study the color? Was that the question? Did we study the color and
Well,
what was the
CNN
Is
CNN
it
in
similar
general
to?
is a higher extracts high dimensional features, so that means it can extract both texture, both spatial features. And since you are entering an RGB color, an RGB painting, that can also extract some color information. But if you're asking what specific color it is, that would be something that is already not one that cannot be described physically. So it's more on the statistical statistical information of colors. So CNN is a high dimensional field, so that means that it can extract a lot of information that that in terms of texture, color, patterns.
So essentially, yeah, what Jem is saying, it's already embedded. In fact, it's more than color. The CNN already embeds pattern, color, texture, even style. That's how high level it can extract feature from data. So yeah.
What's your next, or you want to expand your experiment? Okay, is it purposely more on behavior, the same behavior that they share?
Same
is it
behavior.
possible for that?
We're still, because the question is what's the next
Yeah.
research.
Yep. Maybe
Well, I can
extend the
ask
research, CNN research.
Okay, Jem, do you have any ideas for new research? How to expand this research? It's muted. Can't hear you. Can't hear you.
Can you repeat the answer? We cannot hear you.
Hello?
Hello?
Can you hear me?
Yes,
Yeah,
now,
yes.
yes.
Okay. As of now, what we can see in general in image processing applied on paintings is that there's already a growing research on, so we are talking about art and science as those two disciplines. Right now, there's a growing research on art, science, and psychology. Actually,
Yeah, it's good.
So there are researchers right now that how what can possibly make the paintings give positive emotions or negative emotions. So is the painting memorable? So right now what we can say is that there is a knowledge discovery, there is growing research on those three disciplines, art, science, and psychology.
All right, good.
Very good.
It's really good. Thank you.
Thank you,
Okay.
Jem.
All right. Thank you, Jem. Thank you, for Nolala, for the question. I think that's all. I think that will be the last question for today. So we already passed for the 2 hours. So before I wrap up this session, I would like to, to say a big thank you to Dr. Mariko and also for the student who being in this platform as well. Thank you for your presentation. It's very eye-opening. It's very good to hear it, and it shows that whether whoever you are, what kind of expert you are, if you are physicist or I don't know. There's lots of field in the world, okay. But you can always work with people from different field, with looking at the different perspective, okay. I would just like to tell you, Dr. Michael, we, the NGTF with Puan Laila here, we actually started working closely for the dyslexia initiative, Puan Laila, about the dyslexia program. And I would like to extend the invitation to Dr. Mariko as well. Since in MBTS USN, we have this transdisciplinary and sustainability in art science. It's a research unit. So right now, me and Dr. Najib, as a fellow research at the MBTF, we are working on set up the research unit, and we try to expand our activity on research. So we are inviting anyone from different fields that can work together with us, to enrich for the betterment of art and science. Okay, so yes, with all due respect, Dr. Mariko, you are most welcome to come to visit us again, okay, at MBTS.
Yes, again.
Yes, this goes to everyone here. I mean, for the student, for the first year student, today's session it should be an eye opening for you, okay? Because you are first year student, so you might be, oh, well, I'm going to do in School of Art, blah 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 blah. So there is much more you can be. Okay, you just have to, you know, to build your passion, to build your connection, and try to respect other people from different fields. Okay, and try to work together, and you can achieve more. Okay, you don't have to be, you know, in silo. You don't have to be not try to engage with other people. No, don't try to be that. Okay, so we are living in a world where everything, everyone is interconnected. Okay, so there it goes. Okay, Dr. Mereka, do you have any final word to say?
Except for, I think I said everything except that I'd like to reiterate my thanks for having me. Thank you for the invitation, and thank you for these students who came and stayed for the Q&A, and thank you for your questions. Very much
Okay,
appreciated.
thank you again, Dr. Mariko. So for our audience, okay, please remember the Kuliah atas Talian, KUAT, is an activity that has been done from time to time. So this is our 7th session. We have previously we have 6 sessions already. We have this psychiatrists, we have this with designers, we have this with artists. So we will invite a lot more people to, you know, to share things through this platform. So maybe after this you will have I don't know, surgeon. You have to do something with art. We don't know. Okay, so stay tuned and please follow our Facebook at MBTFSM or Muzium, Tuanku, and Galeri. Muzium and Galeri Tuanku Fauziah. And please follow us, please subscribe to us, and please follow us closely, and you will be surprised what we can give it to you. Okay, thank you everyone for today's session. It has been very good session. Thank you very much, Dr. Michael, and to all the audience. Okay, you can always rewatch this video in our Facebook page. And hopefully we will upload the recorded version also to the YouTube page. Okay. So thank you very much. Thank you everybody. Thank you very much. Thank you.
Dr. Mariko.